Well, I've changed the opening system because I'm going to do it because I've got my portable. Okay, so this graph is meant to show you if you've got just one input, you get huge variations like that. If you have, so say you had one wind turbine, the output would be everywhere. If you have 10 wind turbines, you start to add them up. Because the one's generating when one's not, they start to aggregate. And if you add up 10 signals, you still get quite a big variation. If you add up 1,000 signals, you actually only get very small variation. And that effect's called aggregation. And on large electrical supply systems, that's a very useful thing.
Is that like even when all the wind turbines are in the same place?
True, there is local dependency on the wind conditions, yes, you're right. Still, the second-to-second variation will be smoothed out by having 10 wind turbines in a place. Yeah, we do need to distribute it around the UK. Also, there are times when the whole UK, at the moment, there's not much wind, and hence we're in a low-pressure area. Low? No, in between two, can't remember. And at the moment there's not much wind, so actually it's aggregated, but the actual output is aggregated as very low. So anyway, that's just some terms to be thinking about. Yeah, I'm trying to cover here like all the way from huge national grids all the way down to little 12-volt solar power systems. It's quite difficult to condense it all into one, but we'll try. So. We have this thing called power quality, which is when we're talking about an electrical supply system, we generally mention its power quality. So it's classed as the voltage and frequency stability together with the absence of various forms of electrical noise. It's a relatively dry description. So basically, in the UK, the electricity suppliers have a requirement. It's actually a kind of I think it's a law. Maybe it's not a law. Anyway, they have to supply our electricity at within a certain voltage range and within a certain frequency range. So we generally say that we get 240 volts alternating current out of our plug sockets, and it's generally at 50 hertz. Now, the actual guidelines are you can go down to 47 hertz and you can go up to 50.5 hertz. And then the voltage, we say it's 240, but actually it goes up to 264 and down to 207. So power quality is just ensuring that we're kept within that range. And as we turn things on and off, we are actually affecting the whole national grid. So.
How, like, if you're charging a mobile phone, can that just accept changes in voltage and power?
Yeah, so everything that's designed to be plugged in is designed to work within those tolerances. So that's why the electricity company has to supply within that tolerance. So yes, yeah, everything. Lights, so incandescent lights, they'll just dim a bit. Fluorescent lights can take a wide voltage range input. So everything's designed to work within these parameters. Now,
so in developing countries, when they have like power surges and stuff, what does those regulators, they have like the plug thing which you can...
Right, so kind of UPS systems, which you get surge protectors which stop the devices being destroyed by a high voltage. So that's just a thing to limit the voltage spikes, which can happen when things turn on and off, and if it's not a very strong network. You can also get boxes to plug in, which you would plug in a load that you don't want to turn off. You know, if you have a brownout is when you get a dip of voltage, and a blackout is when you get no voltage at all. So if you have a brownout, your computer could act funny, and you don't want to lose your data, so you put an uninterruptible power supply, a UPS on there. And yeah, if you have bad power quality, so this all comes down to the fact of power quality. In the UK, we have 99.9% power quality. We have amazing grid. It's pretty incredible how it all works, and it's very robust and secure. In a lot of other places, in remote power supplies, you're going to have you're going to have a lower power quality. So the amount of time at which you're outside of the range that you've specified is how you define power quality. So my brother's in Ethiopia at the moment, and maybe 4 hours a day they have electricity and the rest they don't, so their power quality is terrible. They don't know when it's on and off, you know, it's very difficult to run things. Generally what happens, people put in backup generators and but so when I'm talking about power quality, or when anyone's talking about power quality, they mean how often we have a good supply of electricity. And it's a value that we can use for any electricity supply system to talk about how good and robust and reliable it is. Now, having very good power quality is very expensive. So there's a certain trade-off between how much the system costs and how good a power quality you get. So if you're just trying to power some light bulbs, they don't mind if they're undervoltaged a bit for a while. So you don't really need to have very high power quality, therefore you can survive with a low power quality and it's not worth putting in any implementation to make it better. Whereas if you're supplying computers or some other life support machine, something like that, then it would be much more expensive. So when we're designing a standalone power supply system, so this talk was mainly about standalone power supply systems before, I haven't changed the slide. When we're designing a standalone power supply system, we want to supply a reasonable power quality, but supplying anything like the national grid would cost a fortune. You'd have to put in loads of batteries, you'd have to put in additional generators, things like that, and it's just not worth it. So it's not worth trying to match a national scale grid. National scale grid's got loads of inputs and can be robust.
So say you wanted to power your own house with a wind turbine and like loads of other little generators. Would you have to put in loads of protection to make sure it didn't blow up your computer or something?
Depends on how you do it. Are you meaning an off-grid system, or are you meaning grid connected?
Like, I mean a standalone. I know it's quite hard to do, but if you wanted to make a standalone thing, but it's not really worth having a good, high quality power quality, how would you protect all your appliances?
There are a few different things. You would generally, if it's standalone, and we'll come on to it later, if it's standalone we have to have some form of storage. You can't just have it directly powering. There's no way that would work. It would not work. You'd have to have some batteries.
So you have to be charging your batteries?
Yeah, and then using them later. Yeah, the battery absorbs the excess and supplies the deficit. So, but the battery also needs protection, so we'll come on to that later. So, yeah, there's lots of levels. The battery would be providing that instantaneous. You can actually get very high power quality from a battery. I run my workshop on a small solar power system. Got battery, a few solar panels, and I have my power supply has been better than the building in which I'm in, which has had some power cuts, and I'm the only one that can keep on going. It's great. Although not so great today. If I didn't have my nice electric heater, it would be not as good. Anyway, so we're trying to supply reasonable power quality. So what can we do? We've got this renewable energy source, and we're trying to supply some people, some load, whatever it is, with good enough power quality. So what can we do? We can control the generation to match the demand. Now, obviously with solar power, you can't really do that. You can kind of shade out a bit, but it's not very sensible. But things like micro-hydro or hydro schemes of all sizes, you have this amount of water flowing through. So you could actually vary the amount of water flowing through or control that somehow to supply the demand that's required. You can also control the demand, so if there's not enough power, you tell people to turn stuff off, or you automatically turn them off. Or if there's too much power, you dump it to a useful load, maybe you dump it to a heater, something like that. So you can either control the generation, very difficult with wind and solar. You can control the demand, which is quite a clever way and quite cheap way of doing things, but affects the user. So whoever's using the power maybe doesn't get quite as good power, they get a bit annoyed by it. Or we can use some form of energy storage.